Well, welcome everybody. Hope everybody had a fantastic summer and that you were able to get some relaxing in, and maybe for some of you were able to get some work in, because I imagine some of you might have had some internships and whatnot over the summer. So welcome to Structural Analysis. I'm Dr. Michelson, and in addition to being your Associate Dean here in the college, I'm going to be your instructor for the wonderful world of CE 312. I think that I've had most of you for class before. Some of you I haven't, I'm guessing, right? So for the ones that haven't had me before, don't listen to the horror stories from the ones that have, because they're lying. They're not telling the truth. I'm just kidding. What we're going to do today is just go through the course operation and just some logistics on how the class is going to be taught, go through the syllabus, and then we'll sort of get things fired off. I'm going to break a little bit of a rule of PowerPoints, and I'm going to show you the best slide first. Because I can't help it. So this is a little bit about me, but the best part about this slide is obviously my daughter. This is my daughter, Stephanie. She's been evolving in different stages of the word no, and she's now in, I think, stage 5. So stage 1 is the hearing the word no and not liking it very much. Stage 2 is learning how to say it back to us. She was in stage 3 for a long time where she enjoyed to say the word no back to us. Stage 4 was creative means of saying the word no. It's like, no, I want it now. Or why? You know, but she's in stage 5. So stage 5 is, Mom, can I have some ice cream? No. Okay. Dad, can I have some ice cream? That's stage 5. That's where we're in now. So we're seeing stage 6 crop up here though, which is like negotiating. We're like, clean room, can I do it later? No, do it now. Okay. So, but I'll make sure and let you know, and I'll make sure that when she's a teenager that she hears these videos. Dad, you know. Okay, enough about that. Because I guarantee you I will let her listen to this recording at some point. And so enough embarrassment, Stephanie, I promise. Okay, so I'm the Associate Dean here in the college, so I manage all of the academic processes, the administration and things like that. You have questions about advising or course scheduling and whatnot. They tend to come my way as well. But I am a faculty here in the Civil Engineering Department. I did my PhD at that school up north. I'm a registered professional engineer here in West Virginia. I've been at Marshall now. This is my 10th year here at Marshall this academic year. And I'm a structural engineer, and most specifically, I'm a bridge engineer. That's what I focus on. A lot of my research and efforts have been focused on trying to optimize and develop efficient and economical short-span bridge systems. Primarily short-span bridge systems that are fabricated with steel superstructure. So I'm a steel guy. So if you all are ever interested, I know usually in the spring we teach structural steel design. So I'll be teaching that. I can almost guarantee I'll be teaching that in the spring. But a lot of my work focuses on both the analytical side of things as well as applications in the field. So I try and find any excuse under the sun that I can to go out in the field and do field demonstrations and field testing. So it's a lot of fun. But I don't want to go too long about me. I want to actually talk a little bit about the class because that's kind of why we're here. So let's go through the course operation. And so if you've had me for class before, you'll know that usually the biggest component of a grade in my classes are the homework. And for the most part, that's still the case in here. I do have an attendance grade, and we'll talk about the logistics of that here in a bit. But I have a small portion of the grade for attendance. Homework is a big component. We do have a project in this class. It has 2 submittals. One's usually around the early October timeframe, and one's in November, right before Thanksgiving. And I'll tell you, it's this project. I've had a lot of students say it's actually a fair amount of fun. It's not a terrible amount of work, but it's just a way of sort of breaking from all of the raw computations and just having some fun. Basically, what we're going to be doing is sizing a truss bridge that connects this building to the biotech building next to us. So it's a lot of fun. I think you'll enjoy it. One of the main reasons for that project, though, was to try and give you a reason to open AutoCAD again. So because you are going to have to produce some drawings. So we do have 3 exams in the class. 2 of them are going to be during the semester, and one's going to be during finals week and whatnot. This is the textbook. I don't care if you have a physical copy or a digital copy. Either one's fine with me. Most of the homework is going to come out of this book, and I'll say this: I think that this is the book itself is just a good resource to have. I know nowadays you can find pretty much anything you want via Google. I'll say that for the most part, I mean, I'll just level with you. For the most part, you can find a lot of some of the stuff on Google, but I think this is really one of the best sort of well-organized sources for all the topics we're going to be discussing this semester. So I think it's a good idea to at least have like a copy of this, even if you're not interested in having like this version. I mean, you could probably go on eBay and find a second edition for a few bucks, and it's good to have in your library. Again, the homework's going to come out of this, so as long as you're getting the homework assignments done, that's sort of, I think, what's most important to me. Let's go through how I'm operating the class, and we'll open up the syllabus, see if anybody has any questions about that, and then we'll get into the topics. So first thing I want to talk about is Blackboard. So I'm a very heavy user of Blackboard, and I think that those of you that have had me for class before are aware of that. If you've had me for statics or deformables and whatnot, you know that I use Blackboard pretty religiously for posting all of the lecture notes, posting the homework assignments. So for example, if you log on to Blackboard right now, and I'm going to pull it up here in a second, but you'll see that the syllabus is already posted. You'll see that the lecture notes for the first 2 weeks are already posted, and then as we progress throughout the semester, the lecture notes will populate. Let's see, the homeworks will be posted there, like everything will be on Blackboard. I also make sure that your grades are sort of updated in real time. So at any one point, if you want to know what your grade is in the class, look on Blackboard, and it's usually pretty current. One other technology tool that I would mention is some sort of means of a scanning app, like Cam Scanner is a pretty common one. Microsoft Lens is a pretty common one, but that's going to be how you submit your homeworks. So you'll do your homework, scan it, and submit it via Blackboard. So nothing will really get turned in sort of hard copy. I'll go ahead and mention one thing. I have had students ask, there are some students that have like an iPad and have like an app that they can do problems on, and it'll convert to PDF, and they say, can I use that? Sure, you can use that. I have no problem with that. As long as it's legible and easy to follow, that's totally fine with me. I'm easy to get along with. So just as long as the homeworks are neat, legible, I'm not going to get too strict on things like engineering paper. It'd be nice if you use engineering paper, but I'm more interested that your calculations are neat, that your handwriting is legible, you're using straight edges and things like that. I'm more interested in that than just the medium in which you're depositing your homework on. But yeah, if you haven't yet, I would probably download one of these apps like Cam Scanner or Microsoft Lens. They're kind of handy to have. Another technology tool, this is all sort of kind of the same thing that I'm going to use, is Microsoft Teams. I'm primarily going to use Microsoft Teams for periodic class announcements. So like a good example is, let's say we're in the middle of a homework assignment and somebody asks me a question and I find, ooh, that's something that the class ought to know. Teams is a really quick way of saying, oh, hey, everybody, by the way, on problem 2, you might want to check this out. And so I'll blast it out to everybody. That way, if I'm answering a question from one student, that everybody kind of knows what's going on. I try and keep everybody apprised of everything. And Teams is sort of a quick way of doing that. Like I'll probably still send emails and whatnot to the class, but if there's anything quick that I want to send out to the students, I'll probably do it via Teams. I say that it can serve as a backup for like live lectures if needed. Nowadays, that's more for like if we have some crazy inclement weather, but on those days, I usually try and respect the fact that school is closed anyways. Another thing I'll mention is OneNote. So I'm actually going to pull up the Microsoft team for the class. So if you log on to Microsoft Teams, the channel has already been activated for everybody here. And so here's the channel. And so if I go to just the main post, there's nothing here. But if you go to up top where it says class notebook, okay, so if you click that, I think most of the folks who had me for statics know where this is going, but if you've never had me for class before, I never really do problems on the board. What I do is I do them here on Teams. I do them in the OneNote for the class. And the reason I do that is so that That way, when you're outside of class and you're working on your homework or what have you, you can access the calculations 24 hours a day, 7 days a week. And so what will happen is you go into the class notebook, and what you're going to be looking for inside the navigation is what's called the content library. And inside the content library, what you'll see is every one of the examples that we're going to be doing that semester. So this is actually what we're going to be doing Wednesday. This is what we're going to be doing Friday, and then I'll actually do the problems here. So, for example, let's see. So here's the classification example. So if I go to, let's see, go to here. So I just wrote testing, right? And if you all go to, once this syncs and whatnot, you can see it syncing right now. Once that syncs, if you all open up Teams right now and open up OneDrive or open up OneNote, that testing should show up. So literally every mark that I put on the whiteboard, as it will be accessible to you at all times. And I've found that most students tend to really like that, because I mean, you can even install OneNote on your phone and pull up the notes and whatnot in class. So it's still syncing and whatnot, so we'll give it a little bit. Okay. All right. So Microsoft Teams, OneNote. Other than that, the only other software packages that we're going to use in here, we do have like Chrome, Firefox, Office, stuff like that. There is one software program that we are going to use a little bit later in the semester called Mastan. It is the program that we're going to use to perform structural analysis via computer. It's both, one of the reasons I use that package is that it is both Windows and Mac friendly. But we won't be using that until later in the semester. We're talking like in the late October timeframe and whatnot. But I just mentioned that to you because there are going to be a couple days where we're going to have some software demos, and so that'll be a little bit later in the semester that you'll want to bring your laptops and whatnot to class. Now with that, I do want to discuss attendance. So like I said, I do take attendance in this class. If you've had me for class before, you know the drill. If not, the way that I take attendance is what I will do is I usually start class every day with an announcement slide, and on the announcement slide, I have a QR code. And so if you scan that QR code, it'll take you to a Google form. You just put your first and last name in, and there you go. I started doing that actually as a result of the pandemic. Like my initial reason was I was teaching statics, and I had, 60, 70 people in there. It's real easy to take attendance when you have 60, 70 people if you just say, scan the code. So it worked out pretty well. And so I still do that to this day. Find it pretty easy. So is everybody able to do that? Anybody have any issues? Okay. All right, well that was easy. And I can pull that back up if you need. Let's talk about that, and let's talk about some further logistics. Okay, so that's how I take attendance, and like I said, every day I start lecture with an announcement slide, and the announcement slide's more like about here's when homework assignments are due, here's when the exam's coming up, anything that's going on, by the way, here's the attendance. So you have the first couple of minutes of lecture to scan that in. Just make sure and try and be on time. Try and stay for the total lecture, but that's usually not a big deal in a class like this. I do want to mention the recording. So right now I am recording this lecture. So what's being recorded is everything that's on the screen, which is another reason for using OneNote for the in-class examples, so it actually shows up on the recording, and my voice is being recorded. And what I do is I take this recording and I post it to a YouTube playlist, and that YouTube playlist is linked on Blackboard. So you can watch the lectures, rewatch them, at your leisure. I started doing that. I've been doing that now for like 6 or 7 years, and I think most students respond pretty well to that because it makes the content and whatnot much more easily accessible. Let me pull up Blackboard while I'm thinking about it. So if you log on to Blackboard right now, this is what you're going to see. So, and I want to pull up the syllabus here in a second, but you're going to see the course syllabus. You're going to see a link to the YouTube playlist. Right now there's nothing on there because it's the first lecture. But after this recording gets processed, I'll post it to the YouTube channel, and then it'll it'll be there. And every lecture will be on that list. That way you don't have to have 30 different links. You can just click that one link and they're all there. I will post older homework assignments and the solutions to those homeworks in this file here. So right now there's nothing in there because I haven't assigned any homework. And then I'll post the lecture notes and whatnot in here. So if you click the lecture notes folder, you will see here's the lecture notes for the first couple weeks. And then as we progress throughout the semester, you'll see more and more notes popping in. Anybody have any questions so far? I know I've probably dumped a lot of information on you, although you all are juniors, and so you probably kind of get the drill a little bit. Everybody good so far? Okay. All right. Okay, so what I did in the past few minutes is I kind of just gave you the high-level bullet points. I'll get maybe a little bit into the weeds with the syllabus. So, well, actually, let me qualify that. I'm not going to go through every line of the syllabus in here, but it's there on the course content section of Blackboard, and you all can review that at your leisure. I'll mention a couple things that I think are noteworthy here that I haven't already brought up. Let's see, technological tools, assistant, lecture, homework. So there's some notes here on submission formatting guidelines. Again, like everything that I said just now about the format of the homework still applies here. There's a couple more details here that you probably ought to go through, but again, my main sticking point is I just want to make sure that it's neat and legible. Okay, I do want to say one thing about generative AI. I think probably you're going to be hearing that a lot from some of your instructors if you haven't already. We live in the age of ChatGPT, right? And the university doesn't really have a be-all, end-all policy on ChatGPT. Instead, what they're doing is they're offering suggestions for what instructors should do regarding ChatGPT, and so there's different layers to that. So some instructors might say can't use it at all. Some instructors might say sure, go ahead, and some instructors might say sure with some restrictions. In this course, I'll level with you. I'm really not worried about it for a couple of reasons. One of them being that software package I mentioned earlier. Once I show you that, you're going to kind of see how you can use that to do problems anyways. But the other main reason why I'm not too terribly concerned about it is this class has sort of been described as statics 2. And I don't know that ChatGPT is really all that good at doing statics problems. If we were teaching if I was teaching a course on medieval Russian literature, that'd be a little different, because you can have it write essays for you. I mean, it can do some computations, but I was messing around with ChatGPT and I asked it, what is the standard deviation of this set of numbers? And it got it wrong. So it wasn't right. Because I did it myself. I was like, that's not right. It was close, but it wasn't correct. So I'm not really that concerned about it. So that's pretty much it. The one thing I do want to discuss, though, at this point is the lecture schedule. Now, if you have never had me for class before, I'm going to say something that will probably alarm you, which is that I usually assign homeworks every lecture. Okay, and you're like, are you kidding me? We have homework every lecture? Yeah, but it's not that much. Okay, for those of you that have had me for class before, you know that the homework assignments I usually assign from lecture to lecture are really small. They're kind of bite-sized. We have some homeworks that might take 10 minutes. I started doing that as a result of the pandemic. It was sort of like a means of getting everybody engaged in coming to class. So what'll happen is we'll have a lecture on Monday, and then we'll have an assignment assigned Monday, due Wednesday. And then on Wednesday we'll have an assignment due Friday, and then Friday due Monday. It is the same amount of work that I would assign if I were to take these 30 assignments and condense them into 10 assignments or 8 assignments. It's just taking it and spreading it out. And I remember when I first started doing this, I thought that students were going to be flaying me alive on the course evals. But most students actually really liked it because it was sort of a break from a lot of their other classes that do what we typically do, which is get that really big assignment, have it due on Wednesday. It's like you're an engineering student, you've got all these assignments all due on Wednesday. It's like, oh my goodness. But then there's that one class that just doles it out, very, in these little bite-sized homework packages. So students actually seem to really like it. A couple things I'll mention about the homework. So I make it a point that when we're in exam land that you don't have any homework outstanding, because I want you focusing on studying for the exam. So when we have exams, you'll see that there's like no homework assigned or due. We have one instance where there's a homework due on the exam review day, but for this homework, it's usually pretty small. I try and not give you a lot of work while you're prepared for exams. Speaking of the class schedule, so because of the way that the homework schedule is structured and the way the class is built all together, we do usually have a pretty easy time adhering to the schedule. So like, for example, when we're on lecture 21, that's what we're going to be talking about is internal hinges and shear and moment diagrams. There's literally a lecture for every day. So I do that because I want to make sure that when you're coming to class that we have a reason for being here, that it's not me just, what are we talking about? And me just rambling for 50 minutes. I want you to actually get some value out of the time that you're going to be here. But another side to that is that because the schedule is pretty, I don't want to say set in stone, but it's pretty well defined, the exam dates, that's pretty much when we're going to have the exam. So feel free and mark that in your calendar that our first exam is going to be Monday, September 25th, and that our second exam is going to be Friday, October 27th. One of the nice things about this schedule, and I've taught this class for a long time, and I've really never had to use this, is I make sure and cancel the Friday before Thanksgiving break. We end up never really needing it. Unless for some reason we have a blizzard in October, I don't really think that's going to happen, but I figure it's the Friday before Thanksgiving break. You all can have it easy, right? Our final is going to be on Tuesday of finals week, so Tuesday, December 5th, Tuesday at 10:15. I'm going to say a little bit more about my exams here in a bit, but my exams never really are like time crunchers. I'm not really a fan. When I developed my teaching philosophy, I said I'm going to compile a list of everything that professors did that annoyed me, and I'm going to say I'm not going to do that. And one of the things that annoyed me was when I had a 50-minute class and professor said, here's an exam that takes 4 hours to do. Good luck. I never liked that, and I don't do that here. So let's talk about that here in a bit, about the homeworks and exams. Okay, so like I said, homework, so like I said, what I'll typically do is it'll be assigned after the lecture that we give, and then it'll be due the following lecture. I have here that if the homework is late, it'll be a 20% penalty. But what ends up happening is, so let's say we have lecture Monday, a homework due Wednesday. By that Friday, the solution to that homework is posted. So I won't accept homework after the solution's available because then you'll have the answer, right? But one of the other nice things about this homework schedule is that if you miss an assignment here and there, it's not really a big deal. Now, I wouldn't miss 20 assignments, that's a problem, but stuff happens and you might miss an assignment and it's not exactly the end of the world. So doing homework this way, it's actually a little less stressful than you would think. Like I said, there will be an analysis project. We won't talk about that until later, but we'll talk about that around middle of September and whatnot. Like I said, there will be 3 exams, 2 during the semester and 1 during the scheduled finals week. A couple things about the exams. I don't intend my exams to be comprehensive. And so, for example, exam 2, I don't intend for that exam to cover material that was also on exam 1. I'm always a fan of you have an exam it, test it, move on. Move on to the next topic. But I say I'm using this word intended because there are going to be some topics that bleed over from exam to exam, and there's not really much I can do about that. So as an example, one of the first things that we're going to cover in here is the computation of support reactions. Well, you need to understand how to do that to analyze both trusses as well as to construct shear and moment diagrams. Well, trusses is exam 1, shear and moment diagrams is exam 2. Both exams are going to have some degree of support reactions on that. I can't really get around that. But I'm not going to have truss analysis on the second exam. That is a first exam topic, and then we move on. Okay. The other thing that I do during my exams is I try and fabricate my exams based on what I call a rule of three. And what I mean by the rule of three is if I give you an exam and I give you 60 minutes to do it, I better be able to do it in 20 minutes. So literally what I do is I build an exam and I hit a stopwatch and I do the exam, okay? And if it takes me longer than 20 minutes, if I violate that rule of three, then I will pare the exam back. I will say, that problem's too long. I need to trim some stuff off that problem to make it a little more doable. Again, it always bugged me when a professor gave me, this super long exam and no time to do it. And then it didn't really become a test of my abilities as an engineer. It's how fast can I write numbers on a sheet of paper? I'm like, that's not really an examination of my skills as an engineer. It's just, you're just wanting to see how fast I can write. I didn't really find that to be very valuable. So I try not to do that here. And that, I can tell you that is, like I said, the exams are not going to be time critical. That's definitely true of the final. I assign the final. We have 2 hours to do the final. Within the first hour, hour and a half, most of you are already gone. So that's not what I'm trying to do here. I said a lot just now. Does anybody have any questions just in general about how the class is operating, how we're going to do things? Again, for the most part, if you had me for statics, kind of the same way of doing things. So. Okay. Now, before we leave, I'm going to spend a few minutes talking about this. Everybody in here put cash money on the table to be in this room. And by that, whether it was a scholarship or financial aid loans, your parents paying for it, what have you, paying out of pocket, somebody's putting money on the table for you to be in this room. And I want you to understand why you're taking this class. And I always make it a point to do this for every class that I teach, because this is your lives, and I want you to understand why you're taking this. And yeah, one of the reasons is, yeah, you're majoring in civil engineering, this is a required class. Well, I mean, I could just say bye, but I want you to generally understand why structural analysis is an important concept for engineers. So what I would say is, first off, what is structural analysis? Like, what is this class? What are we doing in here? Well, my definition, and I mean, you can go online, go to a dictionary, go to your textbook, and you can find these long-winded definitions for what structural analysis is. Really, it's the determination of the effects or the responses of a physical structure or system when it's subjected to load. So you take a system, put loads or forces on it, what is its response? That process of determining that response, that is structural analysis. That is what we are here to do, okay? That's what structural analysis is, okay? So I have here, some terminology here, effects and loads. What do I mean by that? Let's talk about examples of effects. Examples of effects could be things like support reactions. They could be the internal forces inside a structure. So you all have had statics, so you know that if you have a system and you put loads on it, let's say if you're talking about trusses, you get internal forces inside those members. Are they in tension? Are they in compression? Are they zero force members? You put loads on a structure, there are support reactions keeping it up, so on and so forth. One of the things that we spend a lot of time talking about in here, which we didn't talk about in statics, are deformations, okay? You take a structure, you apply load to it, it will deform. It will respond by deflecting. It will respond by deflecting. It will respond by rotating. Being able to compute those deflections and rotations are important. We're going to talk about why they're important here in a bit. Now, I say here structural analysis is the determination of response when subjected to loads. What do I mean by loads? Well, loads really can be broken up into two categories. One of those categories are gravity loads. So by that term, stuff that acts in the direction of gravity. So dead loads being the self-weight of the structure itself. Live loads being transient or stuff that can move. Basically occupancy loads, what the structure is being used for. And we're going to talk about this stuff in more detail throughout the semester. But then we also have environmental loads. So things like wind. Another gravity effect might be rain or snow or ice. We don't have to really worry about this on this side of the country, but if we were out in California, we'd have to worry about earthquakes. Okay, so those are loads that are applied to structures, and then structures respond, and understanding those responses are important. Now, why are they important? Why do we care about structural analysis? Why we need that? Well, we need to be able to analyze structures in order to design them. That's pretty much it in a nutshell. If you have I'm going to use the bridge engineer terminology, but if you have a bridge out in Barboursville and you know it's going to be 50 feet long, you know the traffic load it's going to carry, you know the general geometry of it, you need to understand those loads and those effects and those responses in order to be able to size those elements. How deep do the beams need to be? How many of them do we need? How far apart are they braced? How many shear studs do we need? So on and so forth. Those questions need to be answered because that's what you need in order to be able to build the bridge. Okay? And so that's why we're in this class. That's why you take structural analysis, is because you use the tools in structural analysis in order to design. Okay? And what is structural design? Structural design is sizing and arranging the components of the structure to make sure it can safely support the loads it's going to be subjected to. So we're talking about beams, columns, connections, all the components necessary to keep the structure upright. Whether we're talking about buildings or bridges, it's all the same concept. Where do we start? Okay. Well, we need to adopt some basic tools. And in the land of structural analysis, we really have three conceptual frameworks that we start off of. And the first is statics, static equilibrium. So whenever we analyze a structure, a static structure, we have to ensure that the forces it develops, the reactions it sees, adhere to the principles of statics. And that is that the sum of forces equals zero and the sum of moments equals zero across the structure. And again, those of you who had statics, you know what I'm talking about. Okay. I'll level with you right off the bat, and I usually get a big sigh of relief. You will not see the letters I, J, K in this class. We don't do that in here. And there are reasons for that. It's not because I think dot products and cross products are icky. It's because a lot of what we do as civil engineers is we break down structures into two-dimensional representations. And in the land of 2D, you really don't need vector notation. And there are easier ways of doing the analysis. In some contexts, vector computations can actually be a little that can hinder your progress. And so the way I like to describe what we do in here is we take what we learned in statics and we learn easier ways of doing it, but we take those easier processes and apply them to more challenging structures. That's kind of what we're doing in here. What are so there's three conceptual frameworks. Again, first is statics. The second is what I would call constitutive relationships. So those are the relationships between stress and strain. How many of you are in CE 321 this semester? I'm just curious. The materials class. Okay, so if you're in materials, you're going to be doing material testing. You're going to be taking aggregates, concrete, steel, alloys, and applying material tests to them to understand things like the Young's modulus or the elastic modulus of these materials, and so on and so forth. Where this comes from is being able to characterize a material's response to given loads. I mean, and where does that matter for our land? Well, if we're talking about a bridge, things like this can help guide us towards decisions of, are we going to build a concrete bridge? Are we going to build a steel bridge? We're going to build a timber bridge? Well, it depends on a lot of things beyond just, you know, the structural analysis. It depends on the economy and material availability and everything else you're learning in the curriculum. This is obviously kind of important to us here. And then the third tool is compatibility, that the displacement should be continuous. These two we're going to spend a little bit more time delving on later, but basically what we're trying to do is tie a thread analytically between the forces that we put on a structure and how much it deforms at the end of the day. And if you can characterize that relationship well, you can do a lot of really cool things in the land of structural analysis. Now, one of the things that we do in this course is we use these tools to develop what are called mathematical models of structures. And I'm going to say something that's a little, antithetical to everything I've been talking about for the past 30 minutes, and that is that we don't really analyze structures in here. Instead, what we do is we analyze mathematical models that represent structures. Now, we construct our buildings and bridges to try and adhere to those as much as possible, but it is sort of an important distinction to mention. And one of the actual challenges in structural engineering is given a given system, what analytical model should we use? And we'll talk about that stuff. Actually, we'll start talking about it on Wednesday, as what types of boundary conditions we're going to see and so on and so forth. But the idea is to represent the behavior as close as possible. I mean, sometimes we deal with some really complicated structures. We've got this weird bridge in Amsterdam. We've got a Guggenheim Museum in Spain. These are not easy. These are not easy to deal with. But ultimately, what we as engineers try and do is we try and keep it as simple as possible. So what we'll try and do is take these complex structures and resolve them into something that we can handle, right? I mean, even something as basic as a roof truss. I mean, even this is a three-dimensional system. This is sort of what I meant a little bit ago about vector notation. So here we have a complex three-dimensional roof truss system, and I'm resolving it into this, which is something that I can use the wonderful world of Engineering 213, or in this case CE 312, to analyze. Then once I analyze that, I can use those forces to determine how big those roof truss elements need to be, and then I begin the process of structural engineering. We're going to get into the specifics of this throughout the semester. I'll say that you do sacrifice a little bit of accuracy when you start doing stuff like this, when you start taking this and resolving it into 2D. But the question is, we just need roof truss sizes at the end of the day. Is this accurate enough? And for the most part, yes. We have tools like finite element analysis and advanced analytical techniques for when these simplifications are not accurate enough. And we can talk about that stuff later. Right now, what we're trying to do is understand the basics of fundamental structural behavior. And that's what we're going to be doing in here. Okay. Does anybody have any questions? Okay, so a little bit on logistics. So I do not have a homework for you today. Yay. I have a homework for you on Wednesday. That homework Wednesday will be due Friday when you have lecture on Wednesday. So what we're going to be talking about on Wednesday is how to take structures and classify them. And so when we classify a structure, we're really trying to answer two questions. Ask two questions and answer. The first question is the structure stable? And the second is the structure statically determinate? And we'll talk about what that means on Wednesday. But once you go through that lecture and you see the homework assignment that I give you and you see how it's due Friday, you'll really quickly see, oh wow, these homeworks really aren't going to be that bad from semester to semester. And again, like I said, if you've had me before, you kind of get the deal. Any other questions? Well, if that's the case, I'm going to let you out 12 minutes early. Unless you want to stay. I see how it is. Everybody's shaking their head. I see how it is. That's all I got. I'm going to pull up the code one more time, but that's all I've got. I will see you all on Wednesday.